Hey everyone, good morning, good evening, good afternoon from wherever you have joined. Thanks, Asim, for setting up the base, and thanks to IWCON for giving this platform to share my talk today with the audience. Before I start, first let me first share my screen, and cool. I hope the screen is visible. So before we start, the topic that I have today, which is streamlining security with shift left, a cloud approach. Let me firstly give you my small intro, and then I will set up the base, what we are going to discuss, and what it's going to solve for us. Myself, Avinash Jain. You can find me over social media with handle as Logic Bomb. I'm currently leading security charter in a US based startup called Quince, which is shopping online shopping portal selling goods from to India, China, and other places. I'm a cricket player by heart, so when I'm not hacking, when I'm not working, I play cricket and watch football. Uh, I usually write about security blogs, things related to the vulnerabilities that I find on various platforms, things that I do in security or a Medium blog with handle as Logic Bomb. So you can check out logicbomb.medium.com. That's also a quick publicity of my blogs. And this is like what I do to learn. I basically find loopholes in different platforms and keep myself updated with what's going on in security world. Cool. So the talk that we have, which contains our shift left. So before we understand what the complete topic is, let's first understand what that particular word shift left actually means. So this is a picture that you can see on your screen, which has basically two pictures, and these pictures has something in similar. If you can spot that, feel free to drop a comment. So the thing which is common in these two pictures is a red color. So basically, red color being used in the traffic light to halt the traffic, and similarly, the red color, comes in the rainbow, which comes at the end at the end of the rainbow. With your the red color comes at the end of the rainbow, and and the reason why the color red, being used for traffics to halt, and it comes at the end of the rainbow. The reason is that it has the largest wavelength and has it can travel to the furthest distance. As in the Vivcure, the red color comes at the end. That means as you move towards the right side, that means you are moving away from the source. And when you come closer to the source, that means you are basically going to the left side. And this is what a very layman language definition of shifting to the left side basically means. When you coming closer to the source, that means that is actually means shift left. uh, if you are from computer background, you might have seen this bitwise left shift operator. So when you apply this operator, a left shift operator to a number like 25, the resultant becomes 100. That means if you apply a left shift operator to a small quantity, the resultant become exponentially large. Now we will combine both of these definitions to tell you what shift left exactly means in the security world. So and this also brings me to the quote saying that security should not be treated as an afterthought. Security should be brought as close as to the engineers and as early in the SDLC. That means you are shifting to the left of your SDLC cycle, to the source of your SDLC, from when the product being discussed or documented till it got released in the production. That is what we mean by shift left in the world of security. So if we bring security closer to the source, then we call it a shift left security. And the second, the shift left operator slide that we saw tells us that if we apply a shift left to something, the resultant increases to a large amount. And in security, it basically the effectiveness. So as you move from corrective measures to more preventive measures, you will find your effectiveness of your complete security program increases by a large amount. And parallelly, the cost incurred to fix security bugs or to manage your complete security program decreases by a large amount. So combining both of two definitions tells us that if we bring security closer to the source, if we move to the source of the code, the source of the development pipeline, and apply security from the starting, the resultant, that is the cost of fixing security bugs, become very less cheaper to fix. uh, which uh, security should not be just considered into at the end of the as in the cycle, when the bugs are expensive to fix, when there's more reactive than rather than proactive nature of security measures. But security should be considered throughout the whole application development cycle, rather than just fixing at the end of the process. So if I need to tell you the brief definition of shift left, it basically refers to the measures implemented to make sure that security concerns are taken to consideration, not just at the end of the process, but during the complete development life cycle. And the main goal of having shift left security is to identify and resolve those potential vulnerabilities which might occur in your development life cycle much earlier, and much before, when they are very less expensive to fix. Some of the direct benefits that it gives, you get a much better opportunity to see improved security outcomes in your product sooner, which involves various security requirements, suggestions, or security recommendations at early stage. It also saves your time and effort, and also the overall cost of your product delivery. uh, it also brings improved testing, monitoring, and response to your um, uh, to support your security drift detection, and also help to implement security adoptions among the engineers, to make people more accountable and having a strong security adherence. Now, we will see. We have talked about what is shift left, and we talked about what it means in security. Now, let's move towards more practical manner. Now, how to make sure that we are achieving this. So, in order to achieve it in the best possible manner, the most logical place that can be seen in security, where security can be checked, are the code reviews. Now, the series of question arises. How it can be achieved, first and foremost, how we can make sure that every release that goes to the production environment has a proper security sign off, how we can make sure that each and every piece of code that has been changed by your developers is not just going through a DAST or dynamic application security testing, but it also going through broader and variety of security checks, which involves you customize checks depending upon your uh, on your framework, on your features, on your application. Now we would be answering this question in the next couple of slides. In the next slides, we'll be seeing how we can achieve this if your organization is using CI/CD pipeline, or using AWS code pipeline. To give you a very short brief about what AWS code pipeline is, it is basically a continuous delivery service that is used to model and visualize and automate all the steps that are basically required to release your software. It basically uh, consists of three tools. First, code commit. Code commit, you can visualize code commit as GitHub or as Bitbucket, where it manages source code repository services. Code build, which is the heart of this CI/CD code pipeline. It is a fully managed continuous integration service that through which you can compile your source code, run different type of tests, and finally produce a software package that is ready to deploy using code deploy. Code deploy is a fully managed deployment service that has the ability to automate your complete software deployment lifecycle to a variety of compute services, whether it is EC2, Fargate, Lambda, or maybe your on-premises servers. No, this is how typical a very basic architecture flow looks like. There's a developer sitting who pushes their code or pushes the changes to their code repositories, and using something called webhook, which we'll be later studying in the next slide. uh, it comes to know that the changes has been made. AWS code pipeline comes to know that there's some changes made to your code repositories, and that in turn runs the checkout source code, build the package, test it, and finally deploy to various servers on Fargate or maybe your own on-premises servers. Now we talked about uh, the webhook that you seen in the last slide. This webhook is basically the heart of this continuous code hacking. Through this webhook, at the real time, AWS code pipeline comes to know that there are some changes made to your code repositories or to a particular code or a PR being raised, and this helps code pipeline to run those security checks that we will be seeing in the next couple of slides. So in short, uh, this is the magic of the GitHub webhook, which makes it more real time and efficient when secure testing is considered. Code build, we when I was going through the code pipeline components, I said that code build is a heart or is a main component of the complete code pipeline. Why? Because this is the actual place where you run your security test cases. Here it basically consists of multiple build stages where you can write your own security checks which seamlessly run within your developer workflow in the form of this AWS build. We'll be again covering how we can write those builds and how it exactly run, and how what in what manner it exactly written. So build spec, a build spec file being written in AWS code build, which consists of these three parts: pre-build, build, and post-build. Each code build project contains these three parts, which is a collection of build commands and some syntax that you want to deploy, and this is written in a YAML format. This is the file where you actually define all the commands and script and the steps that you want to perform specific security checks. So in the pre-built, you basically set up your dependencies, you pull your scanners, download them. In build, you actually run those scanners or run those scripts or tools, and finally you parse your results. And the post build, you can consume those results which being passed. You can call Lambda. You can push those results to multiple communication channel or to vulnerability management tracker, which is done in the post build component of build spec file, which is written in the code build step. So this is how a typical a build spec file looks like. As we mentioned in the last slide, that it consists of three components, which is pre-built, build, and post-build. So here, if you see the pre-build, where I have actually set up the tool. It is an example of Git secrets, which basically scans your Git repositories for sensitive credentials using Truffle. So in the first component, in the first part, uh, there's a pre-built section where you pull your scanner, set up the tool, and which is ready to run in the build part of build spec, which you can see in the slide. And then finally post build, where it basically up to you how you want to consume those results, whether you want to send them as an alert to some communication channel, or you want to push them to a vulnerability management solution. So post build does that for you. Let me combine the benefits that we get out of setting up this continuous code hacking capability. Is firstly SAST. You can perform source code scanning of of your source code. You can also perform dynamic application security testing, and these are just very not traditional but basic standard check that even one performs a SAS and test scanning over their code and over the application changes. But the other major benefit of having code build is basically you can write your own custom checks. It is not just standard checks which is already there, but you can write your own custom checks depending on your on the on the application, on the framework that you are using. For example, I will be showing us example where we have written our own our own scripts which checks whether whether the Docker image being used by developer are actually a whitelisted image of or not. So you can write your own checks, which makes it uh, you know far better than the traditional systems that we have. This is a detailed architecture of our frameworks. This is how it looks like. Firstly, this happy developer sitting who is ready to push a code, and because of GitHub Webhook, which basically at real time tells the AWS code pipeline there some changes has been made to our code repository. It in turns start AWS code build where all those security checks being written, whether it is dash, SAST, secret scanning or Docker linting, and then it calls Lambda to basically how the post build section where you can pass those results, you can push those results into various communication channel over mail or using SNS or maybe AWS security or for vulnerability management or other communication channel like mail or Slack. This is a screenshot of how the result of secret scanning looks like. This is not formatted, so you have the complete capability and customization that you can modify your code to format the output. So this is the output of truffle hog, which is basically a good secret scanning tool. This is output of OAuth's dependency scanner checker, which basically checks if the library that being used in GitHub repositories are running a previous version, or older version, or vulnerable version of the libraries or not. Docker file linter, header lint being used here to uh, you know to scan your Docker file according to the best security practices. Static code is for static code is analysis Sonar cloud being used here. Again, the result is not formatted, but it is up to your hand, up to you. You can format the results and only present uh, only present what is actually required and trim the unnecessary information noise from here. Dash scanning, I use web apps. So apart from running various different type of security checks, the other major capabilities that it provides is reporting. You can share these results across multiple Slack channels, across multiple communication channels, even to your mailbox. You can even alert your developers that whether the build has been successfully built or not, depending on if any security vulnerability being found out uh, in the changes or not. You can even manage all those vulnerabilities at a single place, so you don't need to run here and there, you don't need to find out a third party tool, but you can use AWS native service, which is AWS security hub, to push all those results into it, and you can manage all those security vulnerabilities at a single place. This is how reporting over Slack channel looks like. Again, not formatted, but yeah, which it shows that capable it shows the capability of communication. You can send those reports to Slack channels, to mails, and parse it according to your need. Vulnerability management over AWS Security Hub. So this is what an extension of our framework. This adds a cherry on the cake that you don't need to integrate a third party tool into this complete framework, but you can use AWS native service, AWS Security Hub, to manage all the security vulnerabilities which being found through your CI/CD scans, where you have integrated security at a single place. Some of the benefits, no doubt, because it is real time, thanks to GitHub Webhooks, which basically runs AWS code pipeline at the real time whenever any code change is being made. Reporting, we as we already said and already seen how results and status can be communicated to different communication channels. The it is highly flexible. As I said, those code build steps are customizable and are modular. You can write your own checks according to your own need, and these are modular, that they're independent of each other. So removing one or adding one does not affect the other modules in it. It is completely automated, and no manual workforce is required here. At a blink of an eye, whenever a code pushes, whenever change is being pushed in the code, the complete framework runs automatically. Vulnerability management, you don't need to go here and there or set up a third party tool, but you have AWS Security Hub where you can manage all the vulnerabilities at a single place. I've recorded a demo to show you. uh, I will I will be just playing it. It might not be that visible, but I would try to dictate as it goes. So this is how code pipeline checks looks like in the code build. I created a code pipeline which is with name as DevSecOps, and these are the code build steps: dependency scanning, dash scanning, SS scanning. So these are basically code build steps that we studied in the first part of the presentation. This is how the output of those security tools looks like. You can go to uh, you can go to different code build set that you have written, and you can see what is the output of those security tools, which you can directly see them in the console. This is the result of Docker file scanning, and this is again the result of source code scanning. So the idea is basically to show you how this looks like in AWS. When you write your code build steps in a modular and customizable way, this is how it looks like, and this is how where you can basically check those results. Cool. I think, yeah, that's all what I have from my side. If you have any questions, I'm happy to pick them. And here's the if you have any questions apart from the particular session, I don't know, we have time left, but even if you want to, even if you want me to reach after this session, you can reach out to my mail ID, which is avinash.logicbound@gmail.com, or my Twitter handle, which is logicbound_1.
Thank you, Avinash. That was quite a session. There's a question. I'll just put it on stage. So, any SaaS tool available to perform source code review for low code application frameworks? And the person is using a platform named Woppler, and its backend is based on Node.js, but rest they have their own custom code base.
This, I think, the most popular SaaS tool which is being used nowadays is SamGraph. You can write your own rules there based on your platform, your frameworks, or your tech stack. Uh, and talking specifically about Node.js, I haven't come across any such tool which just target a particular backend service or particular language. But yeah, I think SamGraph can be the better option here.
Okay.